Hey everyone, you know the drill. Get started by logging into Clever. All right, so it's kind of hard to draw a picture in an Edpuzzle, but if you could go and find an image uh, online that describes your mood this morning, you can copy and paste the link and put it here. I want to hear how you're feeling this morning. Awesome. Thanks for sharing those. Those were funny. So, welcome to week 2. This is lesson 3. We're going to start to talk about what a polar molecule is. And by the end of the week, be able to identify that water is a polar molecule, and that's why water is mad cool. So, some reminders and some announcements. First of all, I wanted to let you guys know that your grades for the first semester were posted last week. You should be receiving a report card home in the mail here shortly. So I hope that ended up where you wanted it to. But if it didn't, the great news is that we have a total reset with the second semester. So I hope that you are ready to come here, show up strong, start out performing at a high level, and kick some butt in the second semester. So speaking of semester 2, we made it through week 1 last week. I spent a lot of time doing some grading and getting caught up on things. Remember that if you didn't get it done last week, that's okay, because you can do and turn in any makeup work at any point. I am going to highly recommend trying not to get too far behind too early in the semester and trying to stay on top of it. But realize that even if the due dates are passed, you can do any of that makeup work whenever it works for you. Speaking of due dates, remember I kind of changed our setup. Instead of everything being due on Sunday at midnight, I'm having things due on the day that they're assigned. That kind of just spreads things out so you can better see and visualize when things are supposed to be done and help keep you a little more organized. Remember our expectations, and as always, I want to show appreciation for you being here, but also don't give yourself some love. Appreciate the fact that you showed up and are here today to do the work. This week, we are talking about what makes water exceptional. So, diving into covalent bonding and particularly polar and nonpolar bonds, and then polar and nonpolar molecules. We're then going to look at water and identify it as a polar or nonpolar molecule, and start to make some connections from water's properties to its structure. So there are 2 assignments. This number 6, polarity Cornell notes. That's actually what we're going to introduce in our lesson today. And after you complete the number 6 Cornell notes, you're going to do the number 7 polarity practice. Don't try to do the practice without doing the notes first, okay? And then later on in the week, I'll report back on what that's going to look like, but we are going to focus in on water. Okay, as always, remember that you do need to watch these lessons first before you give the assignments a shot, or else it might be a little extra challenging. But you're here right now, so that's all I can ask for. Start strong. Don't get behind this semester. Let's get into lesson 3. So what I'm going to ask is to take a look at this image and answer these 3 questions for me. So describe what is going on in this image, particularly describe the bond that you're seeing here. See if you can identify what type of bond it is. There's some really obvious clues. And then what can you infer, or what can you guess is the electronegativity difference based on what you see going on here? Awesome. So what we see here is a polar covalent bond. It's described right there, and that is kind of proven and shown because the electrons are being shared. They're not being fully taken one way or the other, but they are being unequally shared. The chlorine is stronger and pulling them more towards itself than the hydrogen here is still holding on, but it's doesn't have them equally shared. So we can assume that the electronegativity is going to be in this, sorry, you can't see that right there, but is going to be between 0.3 or 0.4 and 1.4. It's not big enough for it to be ionic, so it's not fully snatching it all the way away. But we do see that there is an unequal sharing here. All right, so now same question looking at this one. Now that we know more about what's going on in different types of covalent bonds. What type of bond is this? What's going on? What can you infer about the electronegativity and describe what you see here? So this is the other side of the coin. This is a nonpolar covalent bond, as it is described here. Whereas in the last picture, the chlorine was pulling the electrons further towards itself. These two guys are equally sharing. Everybody is happy. There's no struggle or strife. That means that the electronegativity difference between these two elements must be pretty close. Well, if we pay attention, it's two hydrogens, so their electronegativity difference is literally going to be 0. So that means that neither is strong enough to pull the electrons more towards itself. Okay, so that's important in us understanding and identifying and seeing the difference between polar and nonpolar. And we're going to dive into that in the notes today. So what I need you to do is open up number 6, polarity lecture and notes. What you're looking for is you're either going to want to use your own piece of paper if you prefer to write notes down as opposed to type them out, or you can open up the lecture notes document in the number 6 assignment. So what you're looking for is you're going to go to week 2 assignments, click on the number 6 polarity lecture and notes. There are 3 documents there. One are the slides that you're going to use to finish this off after we go through the first slide. There's a Edpuzzle recorded version of the lecture, so that if you're somebody that likes to listen as you take notes, you can follow along and take them there. And then the thing that you need right now is this number 6 polarity Cornell notes. Click on that and open it up for me. All right, it should look like this. If you are deciding to do this on your own piece of paper, please set your piece of paper up like this as well. So you need a column for the left and then a bigger column over here on the right. And I'm going to tell you what's going to go in both of those columns right now. So when I say Cornell notes, all I'm talking about is this is a structured note-taking strategy. So it's a structured, formal way for you to take notes as opposed to just writing things down all willy-nilly. It's controlled and it's structured and it's purposeful. So with these notes, the left column is where you're going to write what we call cues. And all that is just like the major theme, or in this case, the title of the slide. You're just going to copy down what the title of the slide is in that left column. Over in the right column is where the bulk of your notes are going to go. That's where you're going to write down and annotate any notes, any images, any definitions, any examples that are in the body of the slide. So don't worry, I'll show you an example here in a second. So hints for note-taking, especially if you're someone that is trying to work on your note-taking skills, it's a good idea to, because it might be a lot of text that you're either annotating or getting your notes from. So it's a lot to write all that down. Instead, if you kind of eliminate words to make it to the bare caveman language, I call it. It's like, instead of saying like, today is Thursday, or today is Tuesday, 1:26. It is 11:46 a.m. And we are starting lesson 3. You might just say lesson 3, 1:26, 11:45, right? Just cut down the bare stuff to make it that basic information that you need without the extra. You can always use abbreviations. That's another great idea to kind of simplify and shorten up what you're writing down. And then always, it's a good idea to add pictures to support or to provide examples in your notes, because for me, a lot of times, like having that visual is a really, really helpful piece. Okay. So we're going to first start by reviewing ionic and covalent bonding. Those are the 2 slides that we're going to do together. The rest you're going to do on your own. So the structure is going to look like this. The title of the slide is what you write in the left column. So you're going to write ionic compound, recall ionic compounds in your left column. And in the right column, this is where you write down the body of the slide. So ionic compounds involve the transfer of electrons to form ions. It's between a metal and a nonmetal, the metal transferring its electrons to the nonmetal. And the electronegativity difference is really big. It's greater than 1.7. Here's an awesome example of the ionic bonds that occur between calcium and chlorine. Calcium loses its 2 valence electrons to these chlorines, who each want 1 apiece to meet their octet, resulting in these ions being formed. Okay, so here's what your notes should look like. On the left, you have your cues. which is the title of the slide. So recall ionic compounds. And then in the right column is where you put your notes. That's the body of the text. You can include a picture here. You don't have to if that helps you remember it. And then another piece here is, as we're going through this, is any of the slides, if there's any questions that you think of or have that you either want to come back to, or you want to make sure you ask me, or you want to make sure that you heard something correctly or read something correctly, always you can write questions that have to do with that particular slide right here underneath your Q on the left column. So you'll write this down now. All right. So I hope that you're kind of seeing this pattern. So let's do this another example together before I send you off to finish taking your notes on your own. So recall covalent compounds. That's the title of the slide. It'll go over in that left column. In the right column, here's your body, the body of the slide that will be the notes in the right. So covalent compounds involve the sharing of electrons. No ions are formed because no electrons are passed. It occurs between nonmetals. And the electronegativity difference is less than 1.5 or 1.6. The electronegativity difference is not big enough that one element is able to pull the electrons all the way over to itself. All right, there's an example of the shared electrons. So again, here is what you should have in your notes. All right, so now we're going to dive into covalent molecules, and this is what you're going to do with the rest of the number 6 assignment, okay? You need to finish going through the slides that are attached, and you need to record those notes in your Cornell Notes document that we just started, okay? So to get us to the end here, your next step are to finish these polarity lecture notes. So using the slides that have all of the slides that you need, you're going to go through and you're going to record your notes in your Cornell Notes document that we just started. Again, if you're someone that likes to hear it as well as like have me kind of, well, fake there, but in an Edpuzzle there to tell you when to pause, show you what to write, remind you, give you some examples, you can always watch this Edpuzzle, which is a lecture of just those notes of the slides here. If you don't need that, you don't need to do it, but I did want to make it available to you. After you finish number 6, you have number 7, which is going to have you put to practice what we cover in the notes. So for me to see if you kind of actually got what was going on in the notes. All right. So both of those assignments are posted for you now. If you don't have any questions for me, get to work on number 6. And if you do, please leave me a question here and I will get back to you when I can. Thanks you all for your work, and I will see you next time. Bye.